Hello everyone, my name is Mustafa. Welcome to my channel, your one-stop destination for immersive walkthroughs and tutorials on databases and data engineering using Google Cloud Platform, GCP. If you are passionate about harnessing the power of cloud technologies to manage and analyze data effectively, you have come to the right place. Whether you are just beginning your exploration of cloud data or you are an experienced professional in search of advanced insights, everyone is welcome here. Don't forget to hit that subscribe button and turn on notification so you never miss an exciting data-filled episode. Today, we explore Bigtable. Bigtable serves as Google's comprehensive, fully managed NoSQL database solution, offering scalability for vast data storage in key value store. It excels in diverse applications including personalization, ad tech, financial tech, digital media, and Internet of Things (IoT). Bigtable is renowned for its support of high read and write throughput at minimal latency. Bigtable ensures swift access to extensive data volumes, facilitating efficient processing and analytics. Within the Bigtable framework, individual entities such as users or sensors are represented as rows, each uniquely identified by a row key. The columns store attributes, which are values specific to each rows, while column families provide a structured means to organize related columns. The grid formed by the intersection of rows and columns accommodates multiple cells, capturing different data versions at distinct timestamps. Additionally, this lab introduces you to the Bigtable page on the Google Cloud Console, offering insight into navigating a Bigtable instance. It familiarizes you with the Bigtable CLI, which is the CBT CLI, for querying data within Bigtable. As part of this learning experience, you will delve into designing an optimal table schema and row key, aligning with the best practices tailored for Bigtable. As usual, let's start our lab. Click on Start Lab. After clicking on Start Lab, you open the lab in an incognito window. Then I copy my password with me. So click on Next here. Paste my password here. So I understand. Just understand the terms and condition here. And would also agree to the terms of service. Yeah, so this is our Cloud Console dashboard. And to start this lab, here are the objectives for this lab. We'd explore a Bigtable instance using Google Cloud Console. We'd configure the CBT CLI for your instance. We would also design an appropriate schema and row key using Bigtable best practices. And finally, we would query data within Bigtable. So just going over the setup and requirements, and as usual, I would list the active account name and would also list our project ID. So activate Cloud Shell from here. So let's wait for our Cloud Shell instance to get loaded. So just got this. And here we are on Cloud Shell. So gcloud auth list. We authorize this. After authorizing, then we can list the project ID with gcloud config list project. So this is our recommended project. That's fine. So the next thing we want to do is we can check if the necessary IAM permission are given. So these are just some setup and requirements that we want to see if we are fine with. So we can go to the IAM identities under IAM. So we can view the rows, and I think our lab has the row. So you can see this service account. It has an editor role on the Compute Engine default service account. So which is what they want us to check here. So we are actually good. We don't need to do this since we already have that role as an editor. So you can see. So let's for the first task today, we want to explore the Bigtable instance in the console. So let's see how a typical Bigtable instance is in the Google Cloud Console. So we'll navigate to Bigtable under database. So under databases we have Bigtable. Let's click on Bigtable. Yeah, so I think this is majorly what we need. The personalized sales, we can click on it. So from the lab, so this personalized sales have been created for us by default before, so we don't need to bother about that. So let's review the details provided for this lab. So they said what is the total number of nodes allocated to the cluster in the instance. So you can actually check that. So you can see we have one node here under this instance. So let's just click that and submit. So we are good. So to navigate the instance details, so we've done that, and we can now decide to edit the instance. So let's decide to edit the instance. So this is it. These are the instance ID. This is the storage type. This is the instance name, and this is the cluster. So what next? What is the storage type for the instance? So the storage type is SSD, like we saw before. Storage type SSD. So we can submit this. And how many cluster ID are contained in this instance? So this is the cluster ID that we can see. Just one. Personalized sales cluster. Yeah. So that's just one. And what next? What is the name of the cluster ID of our instance? So the cluster ID that we have is personalized -sales -cluster 1. So personalized -sales -cluster 1. So I think we are good. So we'll just close that part. We can close this or just say cancel. And so from the table of the cluster ID on the line 4, click the edit pencil icon. So we can do this edit and take a look at this. You can see we are using a manual allocation. The quantity is 1. Auto scaling not enabled. So what next? What is the node scaling for the cluster? So the scaling mode that we are using here, the node scaling mode we are using here is the manual allocation, whereby we'll set our node count for fixed costs and compute resources. So you can read through and you can see that they are telling us that for better instance performance, keep your CPU utilization under the recommended threshold. So it's better to keep it under the recommended threshold and not over. In case if there are like spikes, you can still your instance can still meet up and not just making it the maximum, whereby any little change can lead to breakage. So we are using manual allocation here. Manual allocation. Submit. So how many nodes are allocated in the cluster? You can check. So we have 1 here. So I think we are good to go. We can cancel out of this. Can also cancel out of this. So and we are back in our Bigtable instance overview page. So in the navigation table under instance, let's go to tables. Yeah, we have tables there. So we have one table already created for us, which is the user sessions. So let's answer some questions under these user sessions. What is the cluster ID? Which cluster ID is the table name associated with? So this guy is associated with this cluster, personalized -sales -cluster 1. Yeah, so we are good. Can submit this. So we've just explored some little things in the Bigtable instance. We've seen the tables in there. We checked the overview. We saw the clusters in the instance. So we have an instance which is like what hosts it. We have different clusters in that instance, and we have one cluster here which was called personalized sales cluster, and we can have different tables in different clusters also. So, and in the single course, in the one cluster we have here, we also have one table which is the user sessions table. So that's good enough. So the next thing is to configure the Bigtable CLI. So let's explore Bigtable using the CBT command on Bigtable. So like you've mentioned, CBT is primarily intended for debugging and exploration. So it's a pretty much useful tool for learning the basic of Bigtable. So let's explore some things in Bigtable. So let's modify the .cbtrc configuration file. Let's take a look at that in our Cloud Shell. Yes, so paste our code. It's telling us our active configuration. So you can see this is the Cloud Shell that we are using. This is also the configuration of this Cloud Shell. So we can also see the available instances in the project. If you want to see the available instance in the project, you can do CBT list instances, and you'd see all the instances that we have in this project. So like we showed before, from using the console, we only have one instance here, and that's the personalized sales. Okay. So the next thing that we want to do, we can modify the CBT file with the Bigtable instance ID. So let's do that. Then after that, we would now like verify that we've successfully modified that. So what we are doing here is that we are saving this instance into personalized sales, so that anytime we want to do some other things in Bigtable, we don't need to specify the instance again, since we've already echoed this instance name to be personalized file. You know that when we run this first command, when we echo project, we now use like a template of get the config get value for the project ID. So it's to showing us our active configuration. But now when we want to see when we want to like echo a name for the instance into the .cbtrc file, which is like a configuration environment for our Cloud Shell, so we just echo this instance as personalized sales. So that's good to know, and it's save us time from inputting the instance once and every time that we are interacting with the CBT command. So that's fine. We can verify that we have it here by using the cat command, and you can see here is our project ID, here is our instance. So that's good to go. And the next thing we want to do is we can also see the list of available tables with CBT ls. Don't forget that we've already configured our instance to personalize sales. If you've not configured your instance, it's more often than not, you would more often than not be prompted to specify the instance that you want to see the tables under. So let's run this. So, and you can see user sessions. So the tables that we have here is user sessions in that instance. So that's all for task 2. We've configured the Bigtable CLI. The next thing we want to do is we want to design a schema and a role key in Bigtable. So I'm just going to do an high-level overview of what schemas and role key may be. So if you're asking a question like, what does an individual role represent? For example, an individual user or a sensor. So that would be more of, you want to identify the role structure. If you're asking a question like, what will be the most common queries to this data? So the most common queries to this data would help you in designing your role key. So when you answer those questions, that will help you influence your choice of role key. What values are created for each roles? So the values that are created for each roles are like used to identify the columns which are referred to columns qualifiers. So what values are collected for each rows would be like the identifier of or the qualifier of each column. So are there related columns that can be grouped or organized together? So this can help you identify the column families that you'll be using. And that's pretty much some questions that you may have along the line. So let's get started, and you can take a look at this example. So the raw data can be organized as follows, and here we have timestamp. These are some example timestamp. These are some user IDs. These are preferred color, green, blue. These are also columns: red skirt, red hat, orange shoes, and you can see that some of the columns are filled, some are some are not filled. So you can take a look at this to have like more thorough understanding. So let's consider a data set that contains online shopping sessions for all users of an e-commerce company website. So each row represents an individual online shopping session with timestamp. So each row, and they have individual online shopping session with their timestamp. Okay, the most common queries to the data set that would retrieve details about individual sessions and the associated user ID. So the most common queries of data sets, they want to retrieve the individual sessions and the associated user ID. So the values stored for each shopping sessions are all items that the user interacted with and purchased during the session, as well as a color preference for that user. So they have a color preference, and they also have individual choices during their own session. So looking at this person now, his preferred color is green. He checked the red hat, checked the orange shoes, and yeah. So this one also preferred color blue, checked the red hat, and the sale was blue blouse, ash blue bracket. So these are just like a sample of how a table in a Bigtable instance can be. So the raw data can be organized as follows, as we have here. So feel free to explore it. And the user ID provided in this example is just is intended as a simple example of an identifier. So typically, you may need to generate a universally unique identifier. That's UUID for each user. So which will be like very different for each user ID sessions. So let's create a test table in Bigtable. So we want to create an empty table, and we'll name the empty table test session. So we'll use this command, the CBT create table test sessions. So let's go to our Cloud Shell. So to create a table, you do CBT, then the create table, then this test session will be the name of your table. Feel free to change it to the name that is applicable to your use case at that particular time. Then strike on enter. So our table has been created. So if you want to also create column families, but before we do that, let's actually check if our tables have been created. So let's refresh this guy here, and you can see we now have test session. It's still under the same cluster that we specified under that instance. So we have that here. Okay, so let's just continue with the proceeding of this lab. So we want to create column families, and in Bigtable, here are some best practices for column and column families. The first one is that you are using column qualifiers as data so that you do not repeat the value for each row. So the column identifiers, let's say in here that we want to, that our column identifier was preferred color. So we just use the column identifier to be preferred color. So in this case, you are not saying, oh, preferred color green, preferred color blue, preferred color blue. So you already know that, oh, this column identifier is the preferred color, and you can input the corresponding results on that under that particular column. So another thing is organizing related columns in the same column families. So you want to organize them related columns in the same column families, and choosing short but meaningful names for your column families. So here are just like some best practices that you want to hold into consideration when creating that. So you can see that we also have different column families here, where we have the red skirt, red hat, orange shoes, and we are just putting scene under them, and not just doing them haphazardly. So following the best practices for column families, which option efficiently organize related columns into the same column families? So let's see. All columns in one column family? No. All columns in one column families with the exception of sales? No. Red skirt, red hat, and orange shoes stored in one column family, and sales stored in another column family? red skirt and red hat stored in one column family, orange shoe stored in another column family, and sales stored in another column family. So I'd say red skirt, red hat, and orange shoes. So let's see what's actually correct. So taking a look at this, I'd pick this. So the correct answer here is actually red skirt, red hat, and orange shoes stored in one column family, and sales stored in another column family. And it actually makes sense also because this red skirt, red hat, and orange shoes are like they are similar pattern. And if you look at here, we are just using sin among all those three columns. So it's safer to store them under one column family than sales under another column family, because they have this part have similar rows, similar results in their rows. And so we'll just pick this and it would be correct. So sorry for the first wrong choice. So for this data set, and it's just bringing it once again, the column qualifiers that stored product interaction can be grouped into one column family named interaction, while the column qualifier that stores purchases can be organized by itself into another column family named sales. So if we are doing that, this first part that stores the product interactions can be grouped into one column family called interactions. So we have this part here, we have the interactions, and this other part we have sales. So I think we are good to go. And the next thing we would do is, so for this one we have interactions from here to here, this part we have sales. Okay, so let's see. So let's add a new column family named interactions to this table. So we want to group all these parts together. So let's add a new column family. So if you want to do that, if you want to add a new column family into a table, you'll be using the CBT, then create family, that's the command, then the name of your table, test sessions, then the name of the column family that you want to name it, which is interactions here. So let's paste this command here, strike on enter, and it should create our column family for us. It has done that. So the next thing we want to do, if we also want to add another column family, maybe which is in this case now we want to add another column family called sales. So we'll also use similar command, just change that part to sales, strike on enter, and it will also create our column family for us. So you can also see the name of the column families that you've created. So if you want to see that, you just do the CBT ls, then the name of the table, test sessions. So you can do that on it here, and you'd see the name of the column families that you have. So if you want to view the column families under this tables, under the test session, you can just check this edit, and you'd see the column families here. So you can see we have interactions, we have sales. You can add another one if you want to, but for now we are not adding. We've added that already on the CLI. Okay, so the next thing we want to do, let's check our progress. Our progress is complete. So the next task is to create a role key. So we would also outline some best practices for creating a role key. So when creating a role key, it is crucial and important to store all information for a single entity. So a single entity may refer to an individual online shopping session at a particular time in a single role. So a related best practice is to create a role key that makes it possible to easily query and retrieve a defined range of rows. So if I want to maybe query from row 1 to 10, I should have a row key that would make it easy for me to get those rows in that particular range. So here are some best practices for choosing a role key in Bigtable. So the first one is to design your role key based on queries you would use to retrieve the data. So make your role key and the queries that you would use to retrieve that data, make them align. So that's why we would consider what are like typical response, what are the typical data that we want to get from this particular table. Also influence our role key. So the next one is to avoid role keys that start with a timestamp or a sequential numeric ID that causes related data to not be grouped. So avoid role keys that maybe start with timestamp or maybe at a particular time, or sequential numeric IDs that are like repeating and they are repeating in a continuous format. So because this will cause the data to not be grouped, and that would lead to hotspotting. That would really lead to hotspotting and to harm the efficiency of your table. So the next thing is to design role key that starts with a more common value, such as the country. So start with a value that is like general. So make sure your role key is starting with a value that is general, such like maybe a country or something that is general to your organization, and end with a more granular value, such as maybe city, that not changes. So make sure like the first one is very common, something that is general to everyone, and ending with a more granular one, that's the one that easily changes depending on the users. So store multiple delimited values in each role key using human readable string values, such as user ID followed by a timestamp. So if you want to indicate multiple delimited values in each role key, so store them using human readable string. Maybe just concatenate your user ID followed by a timestamp. So let's check the best practices for role key. Let's check some tests. So which role key design supports queries that request record for each online shopping sessions, including timestamp, user ID, and color preference? So this first one, start with user ID followed by timestamp and preferred color. Is that correct? I don't think so, because don't forget that we want to start with something that so let's read the instruction again. Which role key design supports queries that request record for each online shopping sessions, including timestamp, user ID, and color preference? So also know that we want to start with something that is more general before we go to something that is more granular. So start with timestamp followed by preferred color and user ID. So it's a bad strategy to start with timestamp, as this may lead to like hotspotting, like we mentioned. Start with preferred color followed by user ID and timestamp. Start with user ID followed by preferred color and timestamp. So I'm still trying to look at something that is first grouped together. So I can say preferred color first, followed by the user ID and timestamp. So I'd go with this. Let's see. So that's correct. So start with preferred color. Preferred color will be more general. So some preferred color may match, which is fine. So before going to the granular details. So following best practices for role key, which role keys stores multiple human readable string values separated by delimiter? So if you want to store multiple human followed by separated by delimiter, so it's this one. So you have it here, and this is the delimiter. So you have the preferred color, then the user ID, then the timestamp, and you can see that it moves from the one that is common that can be common to multiple people before going to those that are like specific, and we are putting an hash in between. So that's just like a pretty simple way to design a role key. So to support, so let's just go over all this so we don't miss anything. So in the previous section, they said timestamp, user ID, and preferred color were not organized under a column family. So recall from the question about the raw data that most of the queries to this data set will retrieve details about their individual sessions and the associated ID. So we noticed that before, the timestamp, user ID, and preferred color, they were not like organized under like a column family. And since we want to get information across this line, so we have to like like design a schema that supports retrieving something like this. To support this query, a good role key for this table would be a combination of the user ID plus the timestamp of the session. In addition, the role key can include a prefix to label the color preference of each user, such as maybe green. Such as maybe green. Then we now have the user ID. Then we now have the timestamp. So for example, user ID 1939 to make it easy to retrieve all users with a specific color preference. So this is just what influenced them in picking this role key. So they typically use like the preferred color before they now use the ID. They now added a delimiter before the timestamp. So that's the role key that they choose here. So because that can help them to retrieve data across this row. So if they want users that typically like green, so the green also shows in the role key. If they want their user ID also, and maybe the timestamp that these people data actually got ingested, or the time that they actually did that shopping online, they can also get that. So to use a role key to add data to the interaction column family, so let's run a sample command to add data to the table using a role key. So we are doing the CBT. So we will set the table name, which is test session, and this is the role key that we are using, green 1939, and the role key value. So under interactions, we are setting red hat to be seen. So we can copy this command, paste it here, strike on enter. So that's what we are doing here. And the next thing we want to do is, let's say we want to use role key to add data to the sales column also. So similar command, CBT, you set the table name, the role key that you want, then the column family you want, sales. And under that column family, you can also set the column you want, sale equals to blue dress, blue jacket. So you can see we have a column family, we also have the column name, and we set the value in that particular row here. So copy it, strike this command there, click on enter. So we'll also get that. And another thing we can use that, we can also see the data that are stored in the table. So let's see the data that are stored in the table. Well, we can do that with CBT read command and read the data in that particular table. So let's get the data in our user sessions. And I'm just going to drag this up a little bit so you can see these are the two data that we typically put in there. So for the first one, which is green 1939, we have this green 1939 here, and the interaction we have red hat, and it is seen. So for this one, for this blue, under the column family sales, under the column name sale, we have this value also inside. And yeah, that's good to go. And this is the time that those data were actually like ingested into the table. So those data are like real time. So you can see my current time here, 7:37. I'm currently in UTC +1. This time is in UTC. So that's it. Okay. So we can also clean up our test data. So let's clean up our test data. Just copy it and delete everything that we have here. So we've deleted it, and if we do a CBT read test session, we shouldn't see anything again. So let me just do that. Let's confirm that we're typing it correctly. So you can see not found, and that's because we've deleted everything there. We also deleted the table self. So let's confirm. So we are done. So the next thing we want to do is, let's query data in Bigtable. So the instance that was created for us before, we have some data in there. So let's query those data. Don't forget that the table that was created for us is called user sessions. So we just created test sessions to explore some things. So let's go into user sessions. So if you want to see the first 5 rows in user sessions, this is the command that you use. and notice that they are still under the same instance ID and under the same cluster. So we are not really changing anything. We've set those default information in our configuration file under this CBT RC. So let's view the first 5 columns or the first 5 rows in user sessions. So these are the first 5 rows here. This is the blue. This is the row key. This is another row key. This is another row key here. And this like add the values in them. This is another row key. This is another row key. So you can just view those. Then the next thing we want to do is, so these are typically how the data is, and you can explore those data to see how they look like. You can explore them further and see what they were using in generating this. So you can see the user ID is blue O. The user ID is used here, and the timestamp was now used to generate the row key. And yeah, that's pretty much it for this. Yeah, so let's query by row key. And to also query by row key, you want, when you're querying by row key, make sure that your row key is efficient to retrieve queries. So you can, there are different ways to query in Bigtable or to retrieve data in Bigtable. So you can either use by the row key prefix, or using ranges of rows defined by the starting and the ending of row keys. And these are also some of the things that we considered when we were designing the row key. So they just make sense that these are also things that I would consider when actually retrieving data. So for the first one, which is query by row key prefix. So if you want to query by row key prefix, we'll be using the CBT read command. So the user session is the name of the table. The prefix for the row key is yellow. So we want to see a row key that starts with yellow, and we want the first 10. So let's see. Strike on enter. So if you take a look at the results that is given, you will notice that each of the row key that would return a row key that starts with yellow. So you have yellow 10. So yellow 10 here also. You can see the timestamp is changing. Yellow 10 here, yellow 10 here. You have yellow 100 here, yellow 100, and then thereabout. So that's what you would see all through this part. So the next thing we want to do is let's query by specific ranges of row key or specific range of row key. So let's say we want to see results starting from, looking at this example here, we want to see results starting from yellow with the user ID 941 to yellow with the user ID 991. So that can influence. So we can just use CBT read, the name of the table, user sessions, and we use the start and end command. So the start, you get the range of the row key for the start and the range of the row key for the end. So you copy that column, paste it here, just strike on enter. So we also have that, and you can see the different row key that we have here. So they are starting from, they are the one in between that particular range. So let's go back to our query. Okay. So you can see we want to read for this one, and we are saying starting from 941 yellow to 941 this. So you can see the first one is 941, and this is the timestamp. So going towards that way till it gets to the last one in that particular range, which is yellow 991 this. So you can also query the data using the ranges of the row key that are specified. So the next thing we are also going to do is, let's use the third method, which is to query by specific row key. So let's say I know a particular row key and I just want to retrieve data for just that row key. So I can also do a CBT lookup, then the name of the table, user sessions, then I'll specify the value of the row key. So I'm just going to paste it here, click on enter. So it's going to look up that particular that particular row key is going to look up that particular row key, and you can see it retrieves the data for just that particular row key. So we have the interactions, the column family, and the column names under that particular column family: blue jacket, green dress, orange blouse, orange skirt, purple blouse, purple shoes, red blouse. So interaction, user ID, yellow dress, yellow jacket, yellow skirt. And we also have the last one, the last column family, which is sales, and under that we have the sale column, which is yellow skirt. So that's typically all for this lab. So which products was purchased during the session identified as purple 9 iPhone 1. So if you want to do that, you can actually, to get this thing, the best thing to do is to actually run that particular row key. So let's look up this particular data. So this same thing, just put it here. Then I'll change this part to purple. So just copy this guy here. Then let's replace that with purple. Then strike on enter. Let's see. So you can see return the value for this particular row key and which was actually purchased. So you can see what was purchased. What was actually purchased was purple art. So, and that should be the correct answer here. Purple art. Submit. So that's good to go. So here are some other things before we also go. You can also query by the column qualifiers and column families. So let's say we know our column family. Our column family is interactions. So let's read those data in that particular column families, and we just want something like just 5. Just 5 is enough. Yeah, so let's run this guy here, and this is the column family interactions, and we are doing a wildcard.star. So using that, you'd see some ranges of data under that particular place, and we are just using a limit of 5. So you'd see 5 results returned. So you can see for the row key is only showing those interactions because we're only concerned about the data under the interactions here, and that's why it's returning only the interactions results. Another thing that we can do is, let's say we want to query the first 5 rows that have data in the green jacket under the column family interaction. So we can also do that. So you do a CBT read, the table name, the count of the results, then this is the columns. So this is the column family first before the column name first. So the column name is, I'm using it interchangeably with the column quantifier. So that's the same thing as the column quantifier. So we can see it's showing the column family that we specified, which is green jacket, and it's also showing the results, the column family, which is interactions, the column quantifier, which is green jacket, and it's showing the results on that green jacket alone, different from this one that was doing a wildcard of all the column quantifier or the column name under the column family interaction. So that's about this. And what other things? We can also query for the first 5 rows that have data in the sales column family under the sale column. So it's going to run this guy here, and we also have that. So under the sales column family with the sale column quantifier, so it's showing the results of the first 5, and that's it. And what is the result if you run the previous query again by setting the column parameters equal to sale.star? So this is this is just a wildcard. So what is it going to return? So it's saying nothing is returned, same number of columns quantifiers but a different number of rows. So what I think it will actually return here, don't forget that under the sales we only have one column. We only have one columns. So it should still pretty be the same thing. I think it should be pretty the same thing. But let's see. We are setting 5 here. We are setting 5 here. You set 5 here, and we want to set 5. I think it should be pretty the same thing, but we can check that out. So just going to do this. Then let's change this part. And to sales star. So let me confirm the pattern that it's used. So we have the everything in inverted comma, everything in quotation. So can strike on enter. So let's see. So like I said, it's the same thing. It's the same thing because we just have one column here, and it's just returning the same thing for us. So then the next thing we are going to do here is it's just the same. It's the same thing. Same column qualifier, same column qualifier returned, additional columns, an error if this happens now. So it's not an error. So we can say same column qualifier returned, and that's actually what we got because we just have one column under sales. So if you're adding a wildcard, it's still going to return just those one columns. So congratulations on exploring how to manage Bigtable on Google Cloud, and we use the CBT CLI to query data in the Bigtable, and we also designed table schemas and row key using best practices for Bigtable. So thank you very much for staying through to the end of this lab. If you enjoyed this lab, don't forget to like it, comment your thoughts in the comment section, and share it to your loved ones. And see you in the next series of this playlist. And for that to be exploring, creating, and populating a Bigtable instance. Bye for now.